Welcome to the Foundry by Forge College. Last time we looked at how to track success using Solana KPIs. Today we're moving into our applied Solidity development track to talk about a specific part of building token sales that often gets overlooked until the door is already opening. If you've ever seen a VIP list at a nightclub, you already understand the basics of a Web3 whitelist. It's the gatekeeper that decides who gets into the party. While the names on that list matter, the person actually holding the clipboard is the one with the real power. In smart contracts, we call this access control. How you manage this digital clipboard determines how easily you can update your guest list and how you'll handle administrative emergencies during your launch. In Solidity code, a whitelist is usually built as a mapping. Think of this as a super fast digital ID checker. When an address tries to interact with your sale, the contract looks at its ledger and gets an instant yes or no back. The engineering challenge is deciding who gets the permission to write those yes or no answers into the ledger in the first place. We're going to walk through 3 specific ways to set up those permissions, moving from a simple one-person operation to a setup that can handle a massive professional team. Picking a pattern that is too rigid can lead to expensive network fees or administrative headaches if your team needs to make quick changes once the sale starts. Our first stop is the owner-controlled whitelist. This is like a nightclub where the owner refuses to let anyone else touch the clipboard. If 1,000 people show up at once, every single guest has to wait for that one owner to check their name. We built this using a modifier, which is basically a digital checkpoint, called onlyOwner. This checkpoint automatically blocks anyone who isn't the project creator from touching the whitelist settings. It's very simple to code and very cheap to run. The downside is that you've created a single point of failure. If the owner is offline or loses the key to their wallet, nobody else can update the list, and your sale is effectively stuck. Professional scaling requires delegation, a theme we focus on across our Forge College courses. That leads us to pattern 2, lull-based control. Now, the club owner steps back from the door and hires a team of admins, or bouncers, to handle the clipboards. In this hierarchy, the owner's only job is to manage the team. The admin nodes you see here are the ones who do the actual work of adding or removing guests from the digital ledger. This setup keeps things moving. The owner maintains high-level authority, while the admins handle the day-to-day work, making the project much more resilient. But imagine you want to use that same guest list for 3 different events at 3 different venues. You wouldn't want to rewrite the list every time. This is where we use pattern 3, external delegation. Instead of keeping the list inside the sale contract, we put it in its own standalone security booth. When someone tries to buy a token, the sale contract calls out to this external booth to ask if the person is allowed in. Because the list is separate, you can launch a brand new event and just point it at the same list. The main rules of your sale and the guest list are now 2 separate pieces of code. This separation makes your system much easier to manage and audit over time. Building a standalone security booth takes more effort than just handing the owner a clipboard. So why do it? There is a trade-off. Calling an external contract takes more network energy, called gas, for every purchase. However, the benefit is huge. You can overhaul whitelist rules or switch security providers without redeploying your main token sale contract. Balancing that extra transaction cost against the ability to update your security is one of the key technical puzzles you'll solve as a Solidity developer. That security booth pattern is actually the perfect setup for integrating real-world identity checks, which we'll explore in our next lesson on KYC integration. To get your hands on the code for these patterns and explore more Web3 resources, head over to forge.college. I'll see you there.